And good morning, Year 11. Okay, let's jump straight into it. Today we're looking at scientific notation, also known as standard form and significant figures. Important lesson, okay, and you would have seen this before, but let's dive straight into it. We're on exercise 4C, if you were wondering. I've also added some piano music to the background, and I feel like it's just a backdrop than just an echo. Okay, so starting with scientific notation, also known as standard form. So be mindful of that. They do mean the exact same thing. The first thing to be mindful of is it's really straightforward because it just means that your number needs to be in the form of some number, a decimal, every single other number, times it by 10 to the power of something. So every single scientific notation is always in this form. So what does it mean exactly? This number here, not 0. You can't have 0. Then you've got every other number. And then this is the important part here. It's always times 10, but the power of 10 is number of jumps. So be sure to be pausing this video and copying these notes down throughout the recording. Okay, so now let's look at what that means in terms of an example question. Okay, so the first one says, okay, put the following in scientific notation. So that means the first number, 6, point, because that has to be next, 3, and then every other number. All right, now times by 10. Now my power is how many jumps. What that means is, think about where the decimal point was. On this number here, 63,000, there is no decimal point, which means that we can assume the decimal point was at the end. So how many jumps did I do to get my decimal point from where it was to in here where it now is? So I jumped 1, 2, 3, 4 spaces, so it's to the power of 4. And you can always check it. Put that exact answer that you have there in your calculator and it will give you 63,000. If you understand that now, pause it, go ahead and give the rest a go. Otherwise, let's look at the next one. The first number is a 4. Point, every other number, 5, 6, 2, 2. Now I say, okay, times by 10 to the power of, well, my decimal point is here and it's now being moved to in here. How many jumps? 1, 2, 3, 4 again. Okay. Next one. Remember that first number can't be 0. So my first non-zero number is 4. So 4.3856 times by 10. My new decimal point is in here. How many jumps? 1, 2, 3, 4 jumps. 4 again. Now, one thing to notice here. Whenever you've jumped in the opposite direction, notice that time I jumped this way as opposed to the left. It means that it's a negative 4. Okay, and that's something I would note on your book here. The best way to just remember these is if it's 0 points, it's always a negative power. Okay, so your answer for that one, I'll make it red so you know it's part of my answer, is to the power of negative 4. So any 0 points, you do power of negative. And the last one, I'm going to do 1.64053. My decimal point was here, and I had to move it in here. How many jumps? 1, 2 jumps, times by 10 to the power of 2. Okay, it's really nice and straightforward. There's plenty of them to practice in your textbook. All right, the next one is significant figures. Now this is probably got a little bit more to it. But basically, a significant figure is just, in a very basic way of thinking, is how many figures are there in the number. Now, there are 5 rules, and it seems like a lot, I know, but they're not hard rules to get your head around. And I thought this was a nice little summary of the 5 rules. So, copy these rules out, and if you want, you can just put the rule with the number next to it. That's the most important part. And then you can add the example under it if you'd like. So the first rule says that you have all non-zero numbers are significant. Okay, so that's nice and easy. So let's look at this first example here. It says 1.234. Well, it's got 1, 2, 3, 4 digits, so it's 4 significant figures. All of them are non-zero, which means they're numbers that aren't zero, right? So we count all of them as significant figures. So there's 4 significant figures. 1.2 has 2 significant figures. So that's really easy, nice and straightforward. Number of digits is number of significant figures, except 0. Okay, now the next rule says, all right, well, all the zeros that are between numbers are significant, okay? So the complicated part about significant figures is whether to count 0 or not. So it's just saying that every zero that's between, okay, normal numbers are significant also. So this one here, we got 2 zeros. We count them because they're between 2 significant figures, okay? So there's 1, 2, 3, 4 significant figures. This 0 is in between 2 numbers, so 1, 2, 3 significant figures. Nice and easy. Okay, now my next rule, it says zeros to the left of the first non-zero digit are not significant. Okay, so in fact I don't really need that last part, I just need this part. So what's that saying? Any zeros that are on the very left hand side without a number putting them inside of the 2 numbers, they're not significant. So these zeros here and these zeros here, not included. Okay, so whenever there's just zeros on the left and there's no number putting them in between like they did in example 2, they're not significant. So therefore this one, it only has 1 significant figure, and you can see that there with, if I get a different colour, that's the only one we're including. These 2 are the only 2 that we're including. So you don't count zeros to the left. And again, make summaries of what I'm saying here, okay? So if you want to add a little bit of note, say, don't count zeros to the left. Okay, so make these yourself so you can understand this better. All right, the next rule says that zeros to the right of a decimal point in a number are significant. All right, so only the ones to the right of a decimal. So let's think about these 2 examples they gave us. Okay, well this first 0 here is on the left of the decimal, so that's not included. But this 0 here is on the right of a decimal, so it is included according to this rule. As well as the digits which zeros to the right of a decimal point in a number are significant. Yes, sorry, so that should definitely be a 3, not a 2, because you've got your 3 significant figures there. Okay, so just fix that for me. So that is a 3, not a 2. Because you've got 1 to the right, then the 2 numbers. The next example, you've just got a number, definitely significant, and then 2 zeros that are to the right of the decimal, which gives you a total of 3 significant figures. So again, make a summary of this. A summary that you could say is zeros to the right of a number after the decimal point included, and that just brings me back to this first example here. Accept my apology, that is 2. Okay, because what I just realized it was, so just fix this for me. It's the zeros after the numbers after the decimal point, okay? Hopefully that's not too confusing for you, but we don't count that 0 because, yeah, it's a 0 after the decimal point, but the 0 must be after the number after a decimal point. Does that make sense? So for instance, over here, I'll just say 0.01. This has 1 significant figure. Okay, but 0.010 is 2 significant figures because you do count the 0 after a number following that decimal point, okay? But you'll see more examples of this soon, okay? So don't stress too much. All right, and the last rule. says when a number ends in zeros that are not to the right of a decimal, the zeros are not necessarily significant. Okay? So, for instance, let's look at the number, and you don't get tested on this one much because it's a bit of an area that's argued by mathematicians. But let's say like the number 200. So it ends in zeros, they're not to the right of a decimal point, and the zeros are not necessarily significant. So that means it has one significant figure. All right? And it's argued because people say, well, no, but how can that be, the number 200? But it's not really, and I'm not going to highlight that one because it's not really an important one because, again, it's not a great example because it's very arguable. Okay, now, one summary that I'm going to give you, and just find a spot on your page to put this. Let's think about those 4 rules. The idea is, with a number, we count zeros that are between digits. So I'll say do count zeros as significant figures. We don't count them here, and we don't count them here, unless, the extra hard part is just to remember, unless they are after a decimal point. So that's a nice summary. Don't count zeros on the outsides of numbers that are hanging on the end unless they're after a decimal point. That's all of those rules combined. All right, let's do some examples. Okay, name how many significant figures are in the following. If you want to pause the video and give these a go, do it. Otherwise, let's go through them. This one's nice and easy. There's 2. It's a 0 after the decimal points, and it's after a digit, so there's 3. This 0 is not included because it's on the end, but a 0 in between 2 digits is included, so that's 3. This 0 is not included, it's on the left-hand side on the end, but all of these are 2, 3, 4, 5. So remember, this one here, it is on the end, yes, but it's after a decimal point. Okay, this one here, 1, because yes, there are 2 zeros after the decimal point, but they have to be after a number to be included. Okay, 1 here again, then this one's not included, this one's not included, this one is included, and this one is included, so 2. All right, and the final step is not just counting how many significant figures something has, but rounding them to 3 significant figures for this example. And you could be asked to round them to any number of significant figures. The best way to do it is go, okay, count the first 3 significant figures. I go, okay, 1, 2, 3. Now I'm going to put up my little invisible wall. Now it's just like rounding decimals. If the number after the wall is 5 or higher, it's going to be too heavy and push over and make the next number round up. Okay, so remember, 5 or higher, it rounds up. Otherwise, it'll round not down, but it'll stay the same. So, rounding that to 3 significant figures becomes 6.41. 3 significant figures here. All right, this isn't included, but this one is, which is only 2 significant figures, which means I must add a 0, because now that 0 I do count, it's after the decimal point and at the end of the numbers, 1, 2, 3. All right, next one, I can't count that, can't count that, can't count that. 1, 2, 3 significant figures. So in my answer, okay, the idea is your answer should be just about the exact same number as the original question. A common mistake here that I'm going to do in green so you know it's wrong is someone to do an answer of 362. Because they go, oh yeah, the first 3 numbers are significant of 362. Alright, so then they say, okay, so my answer is 362. But then say to yourself, is the number 362 close to 0.00366214? No. So it's not just that number. I still include these zeros because they don't count in my answer. If I said to you, how many significant figures in this number? You'd say 1, 2, 3. which is what the question wanted. And that number there is very, very close to the original question. So that's just always a good little way to check you've done it right. The next one, 1, 2, 3, put my little wall up. So it's going to be, the 8 is going to be too heavy, it's going to push over and make it 1, 4, 7. There's my 3 significant figures. And yes, the number 147 is very close to the number 146.89. And finally, 3 significant figures, 1, 2, 3, put my wall up. My 8 once again is too heavy, so it's going to push over the wall. It's going to round my 9 up, which this one becomes quite interesting, to 16.0. All right. So that's a nice little recap now of your scientific notation of significant figures. I want you to have a go at the exercise for me. All right. So we are on 4C. I will upload this video now, and I will also include this PDF on our Compass page. If you do have questions, ask me. If you're still not quite sure about this, go on to Maths Online and have a look. They do have good videos on this stuff as well.